That way, for whatever questions that you have, we can start with them. Let's start with worksheet 2. That way, whatever questions that you have there, we can go ahead and get answered to start with. So as you're looking at worksheet 2, you've got the column there for the type, and the type is one of 3 things. It can either be an ionic solid, a molecular solid, or an atomic solid, just like what you guys did in the computer program. So that's all it is. You're labeling them as one of those 3. Ionic, molecular, or atomic. Okay. The column over here on the far right is, it says phase at room temperature on Earth, and they give you the actual temperatures for what room temperature is on Earth, what it is on Mercury, and what it is on Pluto. Your job is to figure out, okay, on Earth, is it a solid, liquid, or gas? On Mars, is it a solid, liquid, or gas? I'm sorry, not Mars, Mercury. Is it a solid, liquid, or gas? On Pluto, is it a solid, liquid, or gas? So, the first one there, NaCl, its melting point means we'd have to get the temperature above 800 degrees to melt it, and above 1,413 degrees in order to turn it to a gas. So to start with, are any of those temperatures on Earth even possible for room temperature with NaCl? Can we achieve 801 in terms of room temperature? No. Okay, so Earth and Mercury, or I'm sorry, on Earth, it's all going to be, NaCl is going to be a solid. Mercury, its room temperature there, in other words, average temperature is 450 degrees, and that's still less than the melting point of sodium chloride. So sodium chloride is going to be a solid on Mercury, and on Pluto, that's the coldest temperature. It's still going to be a solid on Pluto. Okay, calcium carbonate has a melting point of 520 and it decomposes at 825. Okay, on Earth, it's still 25 degrees Celsius. That obviously doesn't approach the melting point of calcium carbonate. It's a solid on Earth. But on Mercury, the melting point, or the room temp is 450 degrees on Mercury. So, the melting point of calcium carbonate is 520. So is calcium carbonate, is it still going to be a solid on Mercury, or is it going to be a liquid? Solid. Still going to be a solid, yep. So it's not, so the melting point isn't below 450. Okay, now the next one, sulfur, S8. For Earth, it's still high enough, the melting and boiling points of sulfur are high enough that on Earth it's going to remain solid. But Mercury, 450 degrees. So if sulfur is on Mercury, is sulfur going to be a solid? And actually, let's look at both. So Mercury's temperature is 450. It's greater than 115. That's the melting point of sulfur. And it's greater than 444, which is the boiling point of sulfur. So on Mercury, what is going to be the state of matter of sulfur? Well, it's greater than the melting point and it's greater than the boiling point. So if it's greater than the boiling point, it's going to be a gas. Yep. So sulfur is a gas on Mercury. Okay, on Pluto, you can, unless for some reason things get strange here, I think with most of them you can pretty much plan on Pluto being a solid for everything, because it has a really cold normal temperature, negative 230. But that's what you're looking at. So if the room temperature is greater than the melting point and it's greater than the boiling point, it's a gas. But let's say if it's only greater than the melting point but it's less than the boiling point, what do we then know it's going to be? It's a liquid. So if it's greater than the melting point, but less than the boiling point, then your substance is a liquid, okay? So that's really all you're doing there for those columns of elements. And then the last three questions account for the differences in the melting points and boiling points of the three types of structures. I'll let you look at the three and decipher what you can figure out as to why they have different melting and boiling points. Be looking at whether or not they're like ionic, molecular, atomic. You're going to want to be looking at the connections that they have. So take a look at those and then use that information to explain. The following question, which of these would conduct electricity when molten? So that's something from our notes you're going to have to look through as to which one which will be molten and why. You may know already. So, and then would any of these conduct electricity as a solid? That's probably something that is something that we discussed, I believe, the other day, and from the shocking revelation. So, going forward, any other questions that you guys can think of in terms of working on worksheet 2? Bless you. Okay, otherwise, I just want to spend a couple of minutes doing some other things with worksheet 3 to make certain that we've got information there to work on it. Again, from yesterday, we were looking at how, like the first one in number 1, you want to write out the name for it, Na2O. The first element in the compound is your positive ion. You always write the positive ion as it's listed. Bless you. Which is sodium. And again, for the O, we would normally call it oxygen. That's the element. But what you do is you drop the suffix at the vowel, in which we are considering Y a vowel. So you drop the suffix at the Y, and then you add I-D-E. So the actual name of this is sodium oxide. And then in terms of putting together formulas, what was I doing first? I can't remember if I did lithium bromide with you guys or not, but lithium bromide, you'll want out your periodic table and that sheet that I handed you yesterday, or you can use the one I believe I shared it with you guys electronically, whichever be your preference. Either way, you've got the electronic version and the paper versions. That way you got both. In case you lose one, you always have the electronic version. But on your periodic tables, you're going to want to go back through and figure out what column these elements are coming from. So if it's like column 1A, you'd have a charge of +1, column 2A, those elements have a charge of +2, 3A +3, 5A -3, 6A -2, 7A -1, and then 8 being 0, but we won't use any of the ones from column 8. So that's what you have to do to figure out the charges of the single ions, or if they happen to show up on your sheet, use those too. Lithium comes from column 1, so it has a charge of +1. Bromine has a charge of -1, as it comes from column 7. Now, the charges have to balance each other out when writing the formula, and that's how you're able to determine the formula. So the final formula for this compound will be written as LiBr. So you do not actually include the charges when writing out your final answer for the formula. The charges simply help you to determine how many of each atom you need to have when writing your compound. Let's see. If you're on worksheet 3 right now, let's take a look at 3G. 3G. Aluminum fluoride. Aluminum fluoride. Okay. So, periodic table, what column does aluminum come from? 13. In other words, the thing that's above it, It's, using the Roman numerals.
Oh,
3A.
3A, yep. So, since it's in column 3A, what is its charge? Again, what you might want to do if you don't have it on there yet is you might want to go through and label your columns in your periodic table. Or what you can always do too, again as a reminder, the sample element here, it points to where the oxidation state is at. That also tells you the charge of the element. So, like for lithium, it points to where it's at. If it's just a number there without a negative sign, then you can assume that's positive. So for aluminum, what is the charge of aluminum? Positive 3, yep. So aluminum is +3. What about fluorine? It's in column 7A. -1, yep. Fluorine is -1, okay? So we've got +3 and -1. Okay, so in terms of these two here, how many aluminums am I going to need and how many fluorines am I going to need in order to balance out my charges? Go ahead, Tommy.
1 aluminum, 3 fluorine.
1 aluminum, 3 fluorine. Excellent, yes. So 1 aluminum, Al, and then 3 fluorine, F3. The number of them always goes in the bottom right-hand corner. You'll notice that on 1 and 2 there, as they have formulas written out, the number of those particular elements always goes in the bottom right-hand corner next to the symbol. So 1 aluminum, 3 fluorine, and you don't actually have to write in the number 1. If you write in the element symbol, it's already assumed that there is 1 if you just write the symbol. So if there's 2 or more, that's when you can start writing in your number. Am I going to take you off if you put in 1? No, but just so that you know too, that you can write the symbol without having to put the number 1. Okay, so that is AlF3, and just to show you how they name it, because I know they actually give us the name with it. So it's aluminum, Aluminum, and then originally it's fluorine, Fluorine. So what they do, again, they drop it at the vowel for the suffix. Typically, it's usually like an I that they drop it at. If there's not an I and there's a Y, it's usually I or a Y that they do it at. So they're dropping it here at the I, and they add IDE, aluminum fluoride. Okay, so that's on the front page. On the back page, I want to go to something there too to make sure that we're all on the same page when doing that. Because now what they're going to throw at you are positive elements that come from the middle of the table, the ones that we didn't assign a charge to the columns. So these are the ones that are generally going to have charges that may be anything from like 1 to 4. Okay. Generally what you're going to have to do is when trying to write the name of it, I'll start with naming it. When writing the name, you're going to have to figure out what the charge is. So in fact, taking a look at 5, let's go with 5B to start with, 5B. Okay, you have SnBr4. Now Sn comes from the middle of the table, it's 10. Or no, I take that back. Sn is 10. It actually comes from column 4A. Okay, so it comes from column 4A. Bromine, on the other hand, comes from column 7A. So bromine, it can only have one possible negative charge. So since it's in column 7A, what would the negative charge of bromine be? Column 8A, what's column 8A in terms of their charges? column 8A? No?
Eight is zero.
8 is 0, so if we do,
Seven is -1.
so 7's -1, yes, okay? So bromine has a charge of -1. Now, the formula tells us that there are 4 of those bromines, okay? So if there are 4 bromines, and that has a charge, and one bromine has a charge of a -1, there's only one 10. So what must be the charge of 10 in order to balance it out? +4, yep. Okay, so for any positive element that has more than one possible charge, okay, and this goes for positive elements only. If you've got like 10 that in the periodic table, it says that it can have a charge of 4 or 2. And again, I'm just showing you like how it would appear for the oxidation number as you see the periodic table. If you have something that has more than one possible oxidation state, when you name it, you have to indicate what the charge of it is. We do that by writing Roman numerals. So I would write out the name of this as 10. And since it's a charge of +4, I write in IV for the Roman numeral 4 in parentheses, 10,4-broma. Actually, originally it'd be bromine, but again, I drop it at the I or Y, so I get rid of the I and E, and I add IDE, so 10,4-bromide. I do that for any positive ion that has more than one possible charge. So basically, I think the rest of these on here on the back side are all those that have more than one possible charge. And again, that's only for the positive ion. The Roman numeral indicates what the positive charge is of your ion. Okay, so going over to the other column there, the right-hand column, I'll pick 7C as an example, 7C. Lead 2 oxide. So lead as a symbol is Pb, and since it has the Roman numeral of 2, what is my positive charge of lead? No. Again, what's this here? What's this number right here in the Roman numeral? 4. Okay, 4. Positive 4. So if that tells me positive 4, and I see in 7C, lead Roman numeral 2, what's my charge of lead? +2. Yep. So lead is +2. Okay. Oxygen. Oxygen, I believe, only has one possible negative charge. It's in column 6A. So 8 was 0, 7's -1. So column 6 then would be column 8 is 0, column 7's -1.
So it's -2.
-2. Okay? So, +2, -2. So how many leads, how many oxygens? For my formula. Huh? One of each, yeah, one of each. P, P, yeah. Right, so if they have equal charges to start with, then you only need one of each. Yeah. So PbO. And again, that was written out, the name of it was lead, Roman numeral 2. And again, originally I would have this as oxygen, but for the negative ion, I drop the suffix, I add IDE, lead oxide. So lead, Roman numeral 2, oxide. The positive charge tells you what to write in for the Roman numeral, and that's again for any element that has more than one possible positive charge, and it's only for the positive elements that you do that. Never do it for the negative one, okay? Do not do it for the negative ones. All right, from there, I'll let you go on and continue working. Obviously, what I may do also is give you some time tomorrow to finish that up, and I may also throw on molecular compounds to work on over the weekend. So, all right, go ahead, get busy.